Hello, Mr. Harry, Mr. Ryan, are you right?
Yeah.
Okay, so last lesson we talked about this finding the max number of pairs. We're given list of string, we want to find out the maximum number of pairs. So a string can be paired with its reverse. Okay, so AB pair with BA, AC pair with CA. If it's two character string, so checking two strings can be paired up takes one constant time. If it's just two characters, then we can just simply check if the first character of the first string equals to the second character of the another string, and the second character of the first string equals to the first character of the second string. Otherwise, if it's not a two character string, then it takes n time to check if two strings paired up. Does it make sense? It's similar to check if a string is a palindrome. So how do we check a string is the palindrome?
If reverse is still the same.
Yeah, if it's reverse, it's the same. There are two ways to check if a string is a palindrome. The first way is to reverse it and check if it's the same.
And it doesn't include spaces in palindrome. It doesn't include spaces.
It's not a strict requirement. The palindrome can include the space.
But it doesn't count it as reversed.
That's a very good question. Yeah, but yeah, it depends. Okay. As I said, there are two ways of checking a string to see if it's a palindrome. The first way is to reverse it and to see if the reverse is the same. The second way is two pointer, right? We have 2 pointer pointing the beginning and the end of the string, and then we move it. If it's equal, move it until it meets in the middle. If it's at any position it mismatch, then it's not a palindrome. Last lesson we talked about two methods. The first one is brute force. The one on the left is brute force. The one on the right is using the hashset. The brute force, our task is to find the maximum number of pairs. So we can brute force all the pairs. And we only count one pair once. For example, ij is the same as ji. So when we brute forcing, we need to make sure one index is strictly smaller than another one. Okay, that's why for j, the inner loop for j index is range up to I, so j is smaller than I. Then we check the string at index I is the reverse of the string at index j. Or we can say the reverse of the string index I is the same as the string at index j, and then if it is, then we increment the count. And the time complexity is O(n) squared. This is because when we're checking if a string is the pair of another one, we assume this is O(1) constant because there are only two characters. But if we lose out this, if we don't have this two character string requirement, checking if a string is paired with another one takes O(n) time, then overall this time complexity is O(n) qubit. So the advantage of the brute force is that the space is O(1) constant because it's not using.
What is space anyway?
What's a space requirement? For example,
it's a very good question.
Very good question. Okay, so for this one we use the constant space because look, we define the variable answer Nij. This is constant space. On the solution on the right hand side, we use a set. Okay, so set is the data structure. Why we say it's O(n) space? Because the set, in the worst case, a set could contain all the elements on the given list, right? So if there are n elements here, so in the worst case, the hash set contains all those n elements, right? So this is O(n) space. So speaking of this is the hash set approach. We're using a set. We go through this array once, okay? And we check if it's the reverse. We have seen the reverse before. If we've seen the reverse before, then we increment the counter. Otherwise, we remember the word in a notebook. For example, like here, AB, right? Have we ever seen the reverse of AB, which is BA in the notebook? No. So we put the AB here. Have we seen the reverse of AC, which is CA in the notebook? No. Then we put the AC here. BA, the reverse is AB. Have we seen the AB before on the notebook? Yes. Right? Yes, they will increment the counter. And then we can remove this AB. Given strings do not have a duplicate, so we can optionally delete it, or we don't need to. It's not mandatory to remove it from the hashset. Okay. Okay, so today we're going to talk about another two approaches. Given two string characters, given size of two character string, lowercase, let's say lowercase. For a 2 character string, if both characters contains the lowercase characters, how many possibilities? Okay, so let's look at one. If it's a single character string, if it's a lowercase, how many possibility do we get?
26.
26, yes, A to Z, right? A to Z. 2 character, lowercase, how many possibilities?
26 times 26.
26 times 26, how do we get that? Look at the first character has 26, A to
Use
Z.
a calculator.
Yeah, okay. The second character has 26 possibilities. The first character has 26 possibilities. The second character has 26 possibilities. So they are 26 times 26, right? So for example, if 01, right? 0101, how many possibilities? If the first digit has 2 possibilities, the second digit has 2 possibilities, how many overall? This is binary. 4, yes. 0001 1011, right? 2 times 2. It's the same thing. 26 times 26 is 676, okay? Yeah? That is super smart.
No, you just search that up.
I knew this answer, okay? Okay,
Yeah,
600.
I know you. Like, oh.
You just lazy.
Okay, 676. Okay, so we can use a array, a bucket, right? A bucket containing 676. True or false, boolean, yes or no, right? At the beginning, we set it to false. False means we haven't seen this before. We haven't seen this before. So it's seen equals false times 676, right? This is a hashset. We can replace this, yeah? Now, here, we want to check the reverse if it's in sync. So how do we map each character? For example, AA. Guess AA, where is AA going to be? 676 buckets, slots. So now I'm saying AA, where is it going to be? Come on, guess. What's AA going to be? And where is ZZ going to be?
First.
And the last, right? We can map, right? Because there are 2 characters, so we can map A, then we can map it to 0. B can map it to 1, and Z will be going to be 25, right? So look, A to 0, B to 1, Z to 25. Okay, and then 2 characters, then we can use the first character index times 26 plus the second character. Am I right? So how do we get this mapping? A to 0, B to 1. We can use the ASCII, right? Odd A. You still remember? Odd A equals ASCII. ASCII. Do you still remember? Yeah? What's odd A? What's odd uppercase A? 2 numbers. Do you still remember? The lowercase a is 97. Yeah? The uppercase A is
69.
very close, 65, okay? 65, 97, 65. So odd A minus 97. Okay, so we can odd the first character minus 97 times 26 plus odd the second character. So in this case, we find a way to map, to find the position where we store the Boolean value, which is true or false for the given 2 character string. This is still the same, and we don't need to remove it actually. Okay, when we want to say sin.add, instead we can say sin this index, right? Index equals true. If sin index, then answer plus equal 1. Or we can just simply say answer plus equals sin index. Index is the how do we calculate index? Index is the first character mapping the index times 26 plus the index of the second character. Okay? Basically the same thing as the using hashset. But why are we doing this? Why are we doing this? What's the space complexity of using this one? What's the space complexity?
01.
Yes. Why is it 01? What's the size of this array?
6 and 6.
Yeah. So it's actually 676, but we don't say it this way because 676 is constant. It doesn't change. It's a fixed number, so it's basically the same as 01, okay? If on average the size of each word in a list is m, then the space complexity is O(n). The same time complexity for both approaches. This is the third approach, and then let's talk about the last one. The last one. Okay, so do you still remember? Yeah, we're using set, right? Set stores the unique character, unique numbers. Okay, so if I'm going to say frozen set. What does it mean? Can you guess what does it mean? Frozen. What's frozen mean? I have frozen both of you.
Can't move.
You
Can't
move.
change.
Can't move, can't change. Yeah? Immutable. Okay. So set. If we have frozen set, then we can't change. We can't modify it. Right? It's immutable. You can't really say set another set. Right? You cannot do that. But you can say set frozen set. Okay, frozen set. So this is very useful. How is that useful? So for example, there are two pairs, right? AB to BA, AC to CA. How many elements here? How many elements? How many? 5. Yes, 5. N equals 5. So if I'm saying AB and BA is the same group. Chesley, too noisy, Chesley. No. Okay. If I'm saying AB and BA is the same group, AC and CA is the same group. Two strings, if it's the same group, if they are paired up with each other. Okay, so how many groups are there? How many groups?
Oh, wow.
There are n, right? N equals 5 because there are 5 elements. And how many groups are there? If I'm telling you that a group is that two strings, a group of strings is a pair of strings. If AB and BA, AB pair up with BA, so AB and BA are in the same group. So can you tell me how many groups are there? And if a string cannot be paired with any other string, then it's a group on itself. So how many groups?
3.
3 groups, okay? 3 groups because AB and BA are the same group, AC and CA are the same group, GZ another group. So there are 3 groups. So how many pairs do we need?
2.
2, yes, 2. So how do we get a 2? The answer is 2 because it equals n, the total number of elements minus the group, right? Does it make sense? Okay, so we know this, right? This is given, we know this. So we just need to find out this. And we can use the set to find out. The set is very useful to find out the number of the unique elements, right? You know, this is A, right? Array. So we can go through each word, right? We can go through each word, each string, and do the set on each one. But obviously, this one has to be frozen set. Okay, so if we do the set on each one, then the first one and the third one, AB and BA, will be returning the same frozen set, right? That's the same group. And then we use a set to do that. We use the set to count the number of distinct groups. Return the length of A, which is n, right? Minus, okay, this is very interesting. Frozen set. W for W in array, okay? W for W in A, so we go through each word. And then we want to do this frozen set on that. So AB and BA pointing to same frozen set. AC and CA will be same set. And ZZ will be another set, right? Frozen set. And then after that, we do this length of set. Or frozen set, it doesn't matter, yeah? Okay? Right? So the second expression is G. So this one is just G. Does it make sense?
Yeah.
Okay, this is a little bit complicated, but it's so elegant, right? It's just one line of code.
It's not that elegant.
This works because the string does not have duplicates, right? If it have a duplicate, then this will not work. This may produce the incorrect results. Okay. So to repeat, okay, so we want to find out the number of pairs, the maximum number of pairs. To sum up, yes. So we need to summarize. Okay, so we need to find out the n, which is the n. N is actually given.
Or in conclusion.
Very nice. I see your English lessons finally paid off. Okay, yeah. So n is the total number of elements, right? 5 elements here. And how many groups? The group, if a string AB can be paired up with BA, then these two strings in the same group. How many groups? 2 groups, 3 groups. AB and BA the same groups. AC and CA is the same group. AB and BA the same group. AC and CA another group. 2 groups. GZ itself another group. There are 3 groups. 3 groups, 5 elements. It means that there are two pairs. Make sense? Yes, because one pair consumes one extra element, right? One pair is two elements, so one pair is two elements. So the number of pair is n minus g. And n we are given. The g, we do the set for each one, for each string. For each string. So the a, b, and ba producing the same set. Right? And then we use the set to count the total number of groups. But as I said, we can't perform a set on another set. This is not going to work. So instead, we need to change the set to frozenset, because frozenset is like the immutable constant, similar to tuple, right? Do you still remember the tuple? Yeah, tuple. 1, 2, 3. Instead of square bracket, we use the parentheses. How do you call this? This is square bracket. What do you call this? Parentheses or
Brackets.
brackets? Yes, bracket. Okay. This is square bracket. This is brackets. We use the brackets to.
Brackets is in English, and parentheses can be like
Okay.
You use it. I think parentheses is maths more like.
I see,
know.
but they mean the same thing. Okay. So these brackets, right, means the tuple, immutable, can't change, constant. And here the same, we use the frozenset. Frozenset we can't change. And then we perform a set or frozenset on a frozenset. Then we count how many, the length, we counted how many distinct groups. And then we can do this in math easy.
We learned about what we did on Monday.
What did Ryan say?
No, just one. I mean, what's the takeaway?
So,
Yeah.
we are doing what we done before,
Mm-hmm.
just different approach. So we are counting pairs.
Yeah, we're counting pairs.
Counting pairs which are the same. We only compare it up if they're the same reverse. There's no duplicates.
Mm-hmm.
And for one of them, we have n, which is the amount of numbers in the array, and we count g, which is the groups,
Mm-hmm.
which are paired up for one pair, one group, and if it's just single is just one. And so the answer is the amount of numbers subtract the amount of groups.
Okay, that's good. The terms complexity is O n times m if m is the length of each string in the list. And if it's two characters, it's O n. The space complexity is O n because we're using a set. Yeah, O n times n actually. Okay, if m is a constant, then O n. Okay, that's it for today. Bye-bye.
Bye.
Bye.